Okay guys, hello, I hope you doing okay. As I promised on our first episode today, I'm going to take you through basic steps of creating a simple ERP on a relatively tight budget, and how it's done and how we can do it with the various technologies that are available out there. So I'm a Microsoft person, so I am heavily oriented with Microsoft. So I'm going to carry out these steps using Microsoft SQL Server 2014, and for the IDE I'm going to use Microsoft's Visual Studio 2019. The reason why I'm using such an old, rather relatively old SQL Server version is for backward compatibility. You know, when you're developing an application, you want to consider compatibility. So you might find you want to develop a application with the latest database standards, but you find a company has earlier versions, full versions, not the express ones, full versions which have more features of SQL. So SQL is quite expensive to acquire. It's in the range of thousands of dollars. So companies usually are reluctant to quickly invest into newer versions. So you basically want to be in a scenario whereby your application, if you get a client who is in an earlier version, it is still compatible. You don't have to install SQL Server again. Okay, so I have opened my SQL Express Server 2014. SQL Express is free, by the way, so I'll put the link on the description below. You can download it from the Microsoft site, but it's still, you can develop your databases here, and you can still deploy them in environments where your client has the full one. You know, companies usually have the licensed full versions which run on their servers, so the compatibility will be the same. For development, you can use SQL Express, which is free. Even you can use Visual Studio, which is free. There's a community edition which you get from the Microsoft site, so I will post the links of where to get those on the description below. So now I am logging into my SQL Server instance on my machine, on my local machine. So I've connected to my instance. So what are we going to do today? So today we're going to create a new database. Okay, we're going to create some tables into that database. We're just going to create two tables, a members table and a products table. Then we are going to create a member products table. That's so that you can have the members profile stored onto it. Then we are going to normalize this table, that is to create the relationships such that you can see the relationship between a member and a product and how you connect them together. And that's pretty much how the basic framework in a nutshell of how ERPs work, how ERPs pass data from different objects, then from there we will now move to Visual Basic. We will create ASP. My strengths, there are many options. You can decide to create you can decide to go the PHP way. You can decide to go There's so many other different ways. Python, you can decide to use different ways of how you want to present your application, but in my case I'm going to focus strictly on Microsoft. I have great knowledge and understanding of Microsoft technologies, so I'm going to pick ASP.NET Visual Basic MVC5 model view controller. So we're going to use model views and controllers to pass the various data objects within the application to and from the database. So once we have done that, we will just use a default template. Then we will create a data layer whereby we will create an entity framework diagram which will show us a visual representation of our products and members tables and how they are related. And then from there we will create just a simple login and dashboard. And then with that information I can be able to show you how you split these processes between application development and database development. Some of you might have heard of full stack developers, UX and UI developers, front-end developers. So this is how now you can model your application development path. So with this, having completed these steps, you can be able now to understand that you can be special. You can now specialize in where your strengths are. For my case, my strengths are in the application and the database design. Yeah, I'm not an artist, so I'm not good with colors, I'm not good with designs. I cannot draw a Nike sign as accurately as an artist can. Or you might have an artist that's very good with that but might not be very good at coding. So you can split and hire specialized talent to do each of those tasks separately and merge them together. And that's what all of these big companies do, including Microsoft. So from there, then, you can always give credit to your template creators or the sources of where you got the templates. Or if once you have that understanding, you can actually go to template sites, find certain widgets or templates that you like, and actually select those specific widgets and add them into your project, or take the whole template and make your project look like a presentable application such that when you present it to your end users, they are not struggling to understand the flows of a rigid application. It's easy for them, pretty much just like how Facebook is so easy. You don't really need to be shown exactly what to do. So let's get started. So I'm logged into my SQL Server instance. You can see there I have quite a number of databases of other applications that I've developed in the past. We'll go into those a little bit later. I'll give you some tours on how they work a little bit later once we have advanced into this tutorial and you have a better understanding of exactly what is happening. So you just right click on databases, you select new database. So we're just going to call this database a demo ERP. Yeah, you say okay. So we create demo ERP. You can see we've got the demo ERP right there. So if we go under the tables tab, you can see we do not have anything. It has system default tables. Yeah, so we're going to now create a members table. Our members table will hold in our login information and our user profile. So we're just gonna pick a few attributes which you're gonna add to the members table. So I'll right click on this and say, click on table. So it brings me to the design part of the table. So obviously when you're creating tables, just think about it like an individual must have a national identity card, yeah, or something that uniquely identifies you, like a passport. So the same with tables, it is called a primary key field or an identity field, which identifies unique records. Say for example, my name is Dennis, okay? I have my name, or rather my profile, is my entry, my member entry is created onto a database. So the system or the application needs to identify me uniquely from another member. Maybe there could be another Dennis who signs up to or is created onto the application. So the system needs a way to uniquely identify me. So in that case, we usually have an ID field. Now, the ID field varies. There are several options of how to configure it. If your application is if it's a unique field, like for example, in a school, a student registration number has various other characters that are mapped to when the student is registered, which year the student is registering, and what course they are doing. So for such cases, you can make your identity field customizable or open. And there are some cases whereby you don't really need that. You'd rather let the computer decide that for you. So the computer can automatically create a unique ID field and increment it appropriately as new members or users sign up. So in this case, we are going to use that one that is assigned by the computer, because we let the computer manage that automatically with an identity. So with an identity increment. Let's create an ID field. The data type for an ID field. Now there are different data types that you can have for your fields. So this validation comes in. The reason why we have different data types is for validation. For example, if you are creating an invoice and you're putting in a price, it would crash, or it would crash your system, or it would make no sense, or you would have an error if you were to put text in the price of something, because when it adds up this or sums up the total, there's no sum total for it. Doesn't make sense to add A plus B. There is no total for A plus B, so your invoice would be wrong and your customer would be mad at you. So for that case, we need to validate data. So to help us in our validation process, we need to select the different data types. So ID, you can now determine, for example, a site like Facebook has over 1 million users, so you have to be very careful. You have to plan ahead when you're determining your data type. Now if you know your data type is likely to grow, then you might want to select the appropriate type of data type. So in our case, we know that obviously our application is relatively medium sized, so we probably will not have a table exceeding 1,000 members. So we can use the integer data type for our ID field. Now if you have a busy site like Facebook, or you have a large application that stores millions and millions and millions and millions and millions of transactions, you might want to consider taking a larger data type, such that when the day your application grows to a certain size, it doesn't crash. If you notice, next to the data types there are brackets and numbers. For example, we have here numeric character, or nchar, which is 10. I'm going to come to that in the next field and tell you what that means. So for the ID field, we are selecting integer. Now you can see we have an option of allow nulls. Now this allows you, a null value is a empty or a nullable value. It's a field that can probably be updated later, so it is left open. For this case, ID must always be there, so you cannot be born and have a blank ID. Yeah, so you must have identity at creation of some sort, but you can grow up and eventually get a driver's license later. So something that allows nulls would be like a driver's license, because you don't have it right now, but you probably get it a little bit later. So for the primary key field, always must not allow nulls. That means if you try to enter a record without ID field, you will be redirected to the creation page with a validation error that you must key in an ID. Now, because we are going to set our ID to auto, the computer is automatically going to be doing this for us, so we don't even need to create an ID field in our application. We just send the data as it is, and the computer determines a new ID for us, which is what makes life much easier. You can imagine doing invoices and you have 1,000 members. You don't want to be coming up with IDs for each and every one of them, because they might be buying different kinds of products at different times, and it's gonna be one hell of a messy job for you. So you would rather let the computer decide that for you. So in our case, in order to do that, we select the identity specification. So we make sure that it is an identity. So we just select yes, and you can see the increment. Increment is 1 and the identity seed is 1. So for example, if you're creating an invoices table and you have certain accounting standards, so you might want your invoice to start from certain numbers or to increment by certain numbers. Like, there are some receipt books where you go 1001, 1010, 1020. It could be for some particular reason. You can adjust what unit to increment it with. So for our case, we'll just leave everything at 1, so that if you just add, it goes. If you add Dennis and say, for example, John, it will just create ID 1 for Dennis, ID 2 for John. So let's proceed. Now we're going to create another attribute for a member. We could say first name. So you notice if I put a space, the system automatically adds square brackets. Now that's because when the system is sending something called SQL queries, the system works with a language, just like the language I'm talking to you. The system uses a particular language to send this data to the database, and that's called structured query language. You can read up on that. I'll put a link on the description below for you to read up more on that. So this structured query language is what maps the data to the different fields. So you have to be very careful how you name these, because there are some system defaults and they're included into queries statements, or rather when the computer sends an instruction, or the application sends an instruction to the database, it sends something called a query. Just think of a query as a directive or as an order by your boss. Do a task A, B, C, D. So for you to understand that very well, you have to be very careful of how you assign that task. So that's the same. So in our case, we try to avoid as much as possible using spaces in fields. It's a very bad practice. It could cause you serious problems in future, depending on different technologies you use, and it could actually make you have to redesign your entire application or components of your application, especially if you're not using entity framework, but you're still using OOP, object-oriented programming. So more on to those technical terms later. We are creating a members table. So you noticed the background with a number next to it. That number just identifies the length of that particular field. My name Dennis is DENNIS. DENNIS. Those are 6 characters. So the number of characters is what the bracket means. Now you have to be able to plan ahead. Again, you want to calculate the size of your application, the size of your database, also the size of your fields. If you've ever downloaded or installed the software, it tells you minimum requirements. It must have at least 1 GB or 500 MB space. So when you're designing your application, this helps you plan how big the size of your application will be. Let me put it in even simpler terms for you to understand. If you're going on a journey with a car from point A to point B, and you need to determine how much fuel you're going to use, basically based on the route that you're going to use, you need certain things. You need the distance, you need the fuel consumption and all that. Then you can be able to accurately predict how much fuel you need to put in your car. So it's the same thing. When you're giving minimum requirements in your system, you need to be able to predict what is the minimum space your application needs in order to be installed successfully and run. So let's think ahead. There's nobody whose name will exceed 150 characters. So usually we can say 150 is a safe guess. Now you'll notice the data type. Before I even get there, sorry, the data type, we have nchar, we have big integer, we have date time, everything is all here. Now I choose to use NVAR character. Now there's N character and NVAR or invariant character. Now these are pretty much similar types of data, but the variant character allows for a greater variation. I don't want to go into too many details of those sub definitions, otherwise we'll be here the whole day. I'll send descriptions of each of those data types where you can reference them, read up on them on the description below. So we're gonna set the length for our first name to be 150. Allow nulls, no, because a member must always have a name. We can have middle name, which is a nullable field. Some people don't have middle names like me. My middle name is a full stop, so I will leave that like that. Then my last name, of course we don't allow null, so again we select the length, and we do not allow nulls. Then we have, what else can we put? Email, standard things, email address. So let's just do this a little bit quickly so that we can cover this. Email, phone number, what else can we, what other attribute can we put? I'll come to more detailed things later, encryption things and that, but we'll get to that later. So for now I'll just keep it very simple. So we will have a login username or a username and password. Okay, so email, again we have to be very careful on the length here. We'll just give email a little bit more provision and say, let's assume 350 characters, although it's very hard to get there. We'll do the same for phone number. 150 is reasonable. Username, we can give it a length of 50 characters. I don't think someone would want a username longer than that. Password, we're going to give it pretty much the same. I don't think it's humanly possible to remember a password more than 50 characters, but like me, I used to have this password, supercalifragilisticexpialidocious. It's still long, but it's only 26 characters, so 50 characters is reasonable enough. Then of course we do not allow nulls for that, so we'll leave it we do not allow nulls, so we leave it unchecked. So we can save this as members. Okay, so we've created our members table. So now we will go ahead and create the products table. Again, products, just like members, products need to be unique. Your laptop has a serial number at the back there, it's unique. So for every product, we must always have they're identified the same way. Products also have their own ID cards. So let's repeat the same processes. I'm just going to go a little bit fast now that you understand what I'm doing. So we are going to have ID, we are going to have a product name. Now you can choose how to articulate the attributes of your objects. So for me, I like to still, as much as I know this is the products table and name is name, if you're doing a lot of if you're merging a lot of data, it makes it just easier to have the name of the table before the name of the attributes. It makes it easier, but otherwise with object-oriented programming, you can still leave it as name, and you'll be able to just know that you have to select the products object and then select it's up at the particular attribute that you're looking for. So for me, this is my naming convention, and then instead of spaces I use underscores. That makes it easier for me. The system recognizes this as one word, but my eyes see two words, which makes it more humanly understandable for me. So when I'm coding, I'm not so confused at what I'm trying to say or what I'm reading. So product name, we can say description. Now for good practice, let me tell you something about this description attribute. Now the system uses structured query language. Okay, the short of description usually is desk or DESC. DESC is actually a system statement. So never ever name your description field desk, because your system will try to see that as an internal instruction. Desk is used to sort data. Say for example, order all the members in first name alphabetical order, or let me just put it this way: order all the invoices by invoice number in ascending or descending order. You can actually create a query with that statement, and if your field is called desk, then you will confuse the system, or your structured query language query or your SQL query that is an instruction being sent to the system will completely confuse the system. So always have things full. And if it is something you cannot avoid, then enclose it in square brackets, like what happened earlier. So anyway, description, what else? Price. Now we can do other things like vendor, which we can map to a vendors table, but for now we'll just work with this and then we'll come back to those things later. So we have our product, it has a name, it has a description, it has a price. And for good practice, which is something I also forgot to do in the members, it's always good to store the date created and the date modified in your application, because you want to know exactly when this data came into your system. Think about it like you have a house with guests and you don't really know who came when or where or why. So when food is ready, or when your several main course meal is ready, you know who comes first and who has to queue at the bottom of the line. So anyway, it's just good practice so that you know how your data came into your system and you don't just get surprised on strangers that came, because there are some people that cause damage. You want to know when they came in so that you can be able to trace where they came from. So it's good practice for audit purposes. So in this case, we'll see date created, date modified. Again, date time. If you want to store the time, say if you're dealing with very large data sets or very unique data sets with very sensitive data sets, you want the time matters because maybe it could be a particular season or a particular thing, so it gives you a better analysis of your data. Or if it's a certain time, it could be an indication of a certain event. So for example, if you see a login at 9 o'clock in the morning, just by reading that data you can be able to tell that's the time someone reports to work, say in a clock-in or biometric system. So you can be able to identify, okay, 9 o'clock, this must have been at the time when, so this makes sense. Otherwise it's not possible to. If it was at 11 o'clock, then you ask questions, what was this person doing putting in data at 11 o'clock p.m. Were they trying to hack the system? Were they trying to do something malicious? It just gives you a basic understanding. So in this case, we'll have our date modified, and now we select the data types, and then we can normalize this. ID will repeat, it's an integer. We don't allow nulls. Product name must be there. We can leave the description blank. Price must be there. So if now, here's an interesting one, price, we don't allow nulls, but if something doesn't have a price, by default it is 0. So the system again can automatically fill that in for you. Price, now price is money. You can see we have money type. Now the difference between an integer and a money type on data types, I'll post more notes on data types for SQL for you to read up on that when you, to help you determine the data types that you're going to use for your fields. But the difference between integer and money, integer is a whole number, so there are no decimals on the integer. So an ID does not need to have a decimal. It would be very confusing to have product A with ID number 1.1 and product B with ID number 1.2. It would cause it would be very confusing for everyone. Yeah, and it's very easy to lose the mapping, because should it be rounded off, you will confuse the system with the particular product and possibly map you to the wrong product, which will give your customer a hefty bill and leave them mad at you at your application, and therefore fail to check out, and you lose business. Anyway, so that is the difference. We are going to put a default value which is 0, so that in case I don't put a price, it automatically fills that in. So you're gonna have date, time, date. Okay, again, you can choose whether to leave this blank or not. It's good not to. We are going to leave it not, because as we key in, you don't have to really key in the date manually. The system can do it for you. I'll show you how to do that on the application layer. There are special functions, now functions, that will automatically fill that date in. If you want to go the extra mile for good practice, you can also put a default value, a default now value. In SQL, the syntax is different from in different applications. So for the SQL, you can just say get date in brackets, open and closing brackets. That will give you a default value of now. If you try and put in a product without putting in the dates, it will automatically put the current date and time. So let's just do that. Okay, hello. So we've done that. So we save this table as products. Okay, now I'm sure now you're thinking, oh, I forgot to put the primary key. So we set primary key to ID. That way we know that one must always be unique. There can never be two of the same IDs. Even if you have a million, thousand, billion records, the IDs must always be different. So you're trying to wonder now, how do we relate members to products? So here there is really nothing we can do. This is a separate thing. Products are separate from members, so there's no relationship, so there's no cross-reference. So for that, we are going to need a member products. If I go to a shop, I am me and I like Samsungs, for example. So I am a Samsung guy, so I'll buy a Samsung and so my product will be a Samsung. So member products, that's how we can connect me and my product. That's how you can connect member and your product. Yeah. So we're moving on to that. Let me just save this and set it properly like we did. Save. Let's just add date time here like we did. Date time, date time, date time, date time, date time, date time, date time. Time, date time, date time, date time. Then we save this, get it, default value. Okay, and then we've got date created. So we are ready now to create some cross references. Right, so now we are going to create a new table. Now, because we already have all the main details, we don't really need to put so much. This is something that happens in the background. It's for the system, and basically now where the system makes sense of all the data, we could go a step further and create views, which if now we want to see the more detailed information, we can derive views from picking data from these three tables and display it as one long nice table, which makes life a lot easier, so much easier when you're doing reporting. That's an advanced stage. We'll get to that later. So for now, we're going to create a members and products table and see how the two are related. Right, so again, ID is important because this is a unique identifier. So now here we do not need to have too many things. We already know when the member was created. We already know when the product was created. We already know everything about the product and everything about the member. So the only thing we need to know is what member, what product. I went to buy a Samsung, so you need to know me and the phone I bought. So in this case, we'll have a member underscore ID. Again, naming conventions are good just to make your application neat and also make sense. So it's good to have it like that. Just always have a good practice on your naming conventions. It makes life so much easier, and such that if you're more than one developer or you happen to pass your source code to somebody else, it is easy for them to understand exactly what you are doing. So we have member ID, we have product ID. Okay, so integer, okay, ID, you know, by now you know exactly what I'm doing and it all makes sense. Now we do not allow nulls here on any one of these because obviously we are referencing existing data. So let's make this a unique identifier. Then we save this as member products. Okay, so now we have member products. We map now we can now connect the different attributes. Okay, so now in order to create relationships, we have to ask ourselves certain rules. We have to understand certain rules first, because how you do this, now this is something that took me so many years to master, that if you're a newbie to programming or this is your first database, this is something you need to understand very critically, so that you save yourself a lot of headache, especially when your tables grow. You can imagine a table like in a HR application which has 50 different fields. It could be a complete nightmare, and you could cry and not understand why. So your approach to this has to be very specific. So let us be very clear on this. Members are singular. sets of data. Products are singular sets of data. So there is no relation whatsoever with these. Okay, now member products have different crossways. You can have different ways. You can have many members having many products, or one member having one product, or one product having many members. You get the gist. So those are called the different directional relationships. So in this case, we are going to have many to many relationships. Okay, many, that basically just means many members can have many products. Okay, that is a many to many. Let me give you an example of a many to one relationship. Products and vendors. One product can have many products can have, or rather one product can come from several vendors. Think of a tire like Pirelli, Michelin, what. So you can have your particular product there and have different vendors that provide that product. In our case here, we have members, many members. I don't only have to buy a Samsung, I can buy an iPhone. I still am a member, so I can have an iPhone and a Samsung, so I can have many to many relationships. So in a case of many to many relationships, you have to come to the table that has both, and then you create the relationship from there so that the system will understand. So let's create a relationship. Here we will add the first one. So we'll map the first relationship. So what is it? So in our member products table, we have member ID. So this member ID should map to the members table and map to the ID. So we have our member ID mapping to the ID field. So that way the system will know, oh, okay, Dennis has a Samsung. Okay, so that's how we would map that. Say okay. Then we would also add another one and say on the products table, so the member products, okay, we would map the ID of the product to the product ID. Okay, so that just basically will tell you that, oh, in this particular purchase, this product was sold as a Samsung. Okay, so we have that link there, and then we save. Great. So we've created, we've normalized. The table is normal. So if I add myself, I create a product, I know very well that, hey, Dennis has bought a Samsung, and it makes sense to the system. Now, you might want to visually envision this, and that's where we'll get to entity frameworks. Now, for the interest of time, I'll go on to show you how to create the registration forms, which will put in this data from the application side. But for the sake of demo testing purposes here, I'm going to cut some of those steps short and manually key them in directly. We'll just create two members, or one member and two products, so that we can just get the basic gist of how the objects work with each other. Then from there, as we move more into the application side, we'll now create the different forms and how to submit the data in that particular format. So I'll do the format manually, then I'll in future show you how to make the system send that data in exactly that format from the application layer. So right now we are on the database layer. I'll just do it manually. So we have our tables there. We refresh the table so that we can see our newly created objects. So I'm just going to start with products. I'm going to edit the first 200 rows. I'll put in two products, just the ones I've been using. Like I told you, we don't need to put ID. So when you're sending your data from the application layer, you will not need to tell the user to input the ID. The system will do that automatically. So let's put in a Samsung. So we have a Samsung. This is a Samsung A10 for example. Price, maybe this one is 15,000. Okay, then date created, we can say the date today is 06. Now formatting, this is so important. So again, your date formatting, you can format it from the application layer, you can format it from the database layer. More into that, but by default SQL has, because it's from America, from Microsoft, they by default give it month, then day, then year. Or it may pick from, sometimes it's very confusing, it may pick from your system settings. So if your computer is set, sometimes it picks, sometimes we don't know how SQL works. Sometimes, you know, SQL has its own issues. So to be safe, we know that this is an American product. By default, it goes by the American standard. So just always assume that it is month, day, year. Then you can format it on the application layer for your users depending on where you are. But just know from this part, it's like that. So 06/10, today is 10th of June 2020. Okay. Again, date modified 06/10/2020. Okay, there we go. Sorry, I forgot to put identity seed on products. So let us do that. Okay, so we've put in our Samsung. Okay, we've put in our Samsung, so let's put in an iPhone just to make it interesting. I'm not an iPhone guy, I'm not much of an Apple guy, so I'll guess we have iPhone. I think it's at X, I don't know, I'm just going to say iPhone 12, and we're gonna say, okay, these phones are ridiculously expensive, 56,000. Just put it there like that. Then we're going to say 06/10/2020, 06/10/2020. Okay, so we have our iPhone here. So we have two products there, an iPhone and Samsung. Okay, so the system knows it has an iPhone and a Samsung. Yes, sorry, let us just make this appropriate. Right, so let's create a member. My name is Dennis. For this case, we'll create one member for the interest of time. So my name is Dennis. Told you my middle name is full stop, my last name is Siama. So my email address is dennis@infotechafrica.co.ke. So my phone number is 0722222222. Now again, your formatting here, you can decide how you want to format it. You can use variant character, you can put the +254, or you can put it like that, depending. Username, people call me Deno most of the times. I can just say Deno. Password, we can just give it a default password. Now the password, you can now control things like complexity and all that on the application layer, just to make it secure, but for now we'll leave it like that. You can also encrypt it so that even if somebody opens your members table, they don't see all your members' password. We can do that from the application level. That is more advanced. We can come to that in future series, but for now let's keep it simple. Date created 06/10/2020. 06/10/2020. There we go. So we have created our member. So that's some in conclusion, we've created our products and we've created our members. So we are going to say Dennis got a little bit of money, he's very rich now. He went and bought both products. He bought an iPhone and he bought a Samsung. Okay, so in our member products table, we now ideally you never do this unless you know what you're doing from the database under any conditions, but because we are testing it out, we will do it. But ideally, this is now where your user interface comes in, where you give your customer who is logged in a very nicely laid out carousel or catalog where they can select the products they want and pay for them. So in this case, we're just gonna do it manually. Since we know everything, we know that my ID is number 1. So you can say, instead of calling me Deno, you just call me number 1. So number 1 bought number 1. Number 1 is what? It's a Samsung. Okay. So that is basically saying Dennis bought a Samsung. So you can also say number 1 bought number 2. That just basically means Dennis bought an iPhone. I'll leave it at that. You get the gist. As many members and many products come in, you see why you should never do this from here, because you're going to get confused. Number 2 bought number 1, what were you? It's a mess. So that's where you need an application to help you do this. So with all that said and done, I think for now I can conclude with this and say we have exhausted the first part of our database creation. Okay, so ideally, if you have multiple developers working on a project, if you are the application or the front-end designer, this is what you would be waiting your database engineer to send to you or to give you. So your database guy will design this and then give that to you. So let's now move to the application where things get much more interesting.